Hello, my name is Andrew Fliss with Tektronix and Keithley Instruments. This video will present an overview of guarded measurements for picoammeters. This handy little box allows us to easily demonstrate the effects of guarding and how your quality of measurement can radically decrease without it. So, without further ado, let's take a look inside. Contained inside of our demo unit is a circuit that allows us to demonstrate the concept of guarding. On the left, we have a source input, with high being represented by the red connector and wires, and low being represented by the black connector and wires. Moving to the right, we see that the high input meets a resistor, which for the sake of this demonstration is 100 gigaohms. Moving right again, we see that the low is tied to ground. Also, observe the switch, which allows us to enable or disable the guard functionality of the box. The metal sheet connected to our switch serves as our guard, and when turned on, prevents current leak from the high line. When turned off, it is disconnected from the circuit. Looking at a representation of the circuit with the guard turned off, there is a difference in voltage between the high and low inputs. This means that current can leak from high to low along the dashed lines, which represent our Teflon standoffs that hold our device under test. These supports are very high resistance, but not infinite. When measuring a large resistor, like our 100 gigaohms, leakage current flowing through the supports can be observed. This will impact our accuracy and quality of measurement. With the effect of a resistor in parallel, the practical resistance of the circuit is lowered. This means that the resistance we will measure with our picoammeter will be lower than expected. Now, let's turn on the guard. With the flick of a switch, our guard plate is now connected to the low of the picoammeter. This means that current will now leak from the unmeasured guard to the ground of the picoammeter due to their different voltage potential. However, as we're measuring the high input and not the guard, any potential current leak does not concern us. Now that you understand the concept of guarding, let's move to a more practical demonstration of its impact. In front of me is a physical version of the guard box we have previously explored, now connected to a Keithley 6487 picoammeter to source a voltage and measure resistance. Turning on the 6487, we'll first zero out the instrument and set the voltage. For the purposes of our demonstration today, we will set the source to 10 volts. Before turning on the source, we're going to have to set up the 6487 to measure the resistance of the box and make sure our demo unit has the guard turned off. Now, let's turn on the source and observe the resistance it measures. Looking at the reading we're getting from the 6487, we see a resistance of approximately 98.8 gigaohms. This measurement is close to the expected 100 gigaohms of the demo box's resistor, but let's see what enabling the guard can do to improve our measurement. With the guard now turned on, we observe an increase in resistance to approximately 99.1 gigaohms. Based on our results with guarding enabled, we see a noticeable change in measurement closer to the listed value of the resistor. This measurable difference is due to the guard line removing the leakage current path. This demonstration of guarding is idealized, obviously, but hopefully you can see how you could apply guarding principles to your own low current measurements. Whenever or wherever there is a path from your high terminal connection to ground or low, guarding can be implemented to reduce or eliminate any current that would leak through that path. Thank you for watching. For more information on the products or concepts presented in today's video, please visit tek.com.